All right, let's jump right in. Today, we are going to get you completely comfortable with one of the most essential tools for any programmer, the Java for loop. And listen, this is so important because it doesn't matter if you're studying for a test, trying to write cleaner code, or dreaming of building something cool, mastering the for loop is a non-negotiable first step. So let's get to it.
So let's start by looking at a common way to make a loop, the while loop. Now it absolutely works, there's nothing wrong with it. But notice how the three main ingredients are all scattered? You've got your starting point on one line, your stopping condition on another, and the part that counts up way down at the bottom. It just feels disconnected. And that makes it easier to mess up, like completely forgetting to add the counter at the end.
So that kind of begs the question, right? Wouldn't it be great if we could just bundle all that logic, the start, the stop, and the step into one single super readable line of code? Well, good news. That is precisely the problem the for loop was invented to solve.
And that brings us to the anatomy of the for loop itself. Seriously, you should think of this as your new best friend for any situation where you know exactly how many times you need to repeat something. It's clean, it's powerful, and it's predictable.
Okay, here's the blueprint. It's beautiful, isn't it? Inside those parentheses, you've got three parts, separated by semicolons. First up is the initialization. This is where you create your counter. And this part, it only happens once. Next, you have the condition. Think of this as the gatekeeper. Before every single loop, Java checks this. If it's true, we go inside. If it's false, the loop is over. And finally, we have the update. This runs after the code inside the loop, moving our counter one step closer to the end.
Now this right here is a super critical concept, the exact order of operations. Let's trace it. Step 1, the initialization. Happens one time and one time only, right at the start. From there, we get into a rhythm. Step 2, check the condition. Is it true? Yes? Okay. Step 3, run the code inside. Once that's done, we hit Step 4, update the counter. And then what? We swing right back to Step 2 to check the condition again. Check, execute, update, check, execute, update. We stay in that cycle until the condition is finally false.
And here's a quick pro tip for you. This is a classic exam question and a common beginner mistake. Those two semicolons, they are not optional. They have to be there to separate the three sections. Even if you have a weird advanced loop where one of those sections is empty, the semicolons themselves must stay. Don't forget them.
Okay, enough with the theory. Theory is great, but let's see this thing in action with some actual code. This is where you're really going to see why it's so useful.
Here we go, a classic countup. Let's be the computer for a second. We start our counter I at 1. Is 1 less than or equal to 4? Yep, so we print high 1. Now we update, so I becomes 2. Is 2 less than or equal to 4? You bet. Print high 2. We keep doing this all the way up until I is 4. We print high 4. Then I becomes 5. Is 5 less than or equal to 4? Nope. And boom, the loop stops.
But what if you want to go backwards? Easy. You just flip the script. We start I at 4. Our condition is now keep going as long as I is greater than or equal to 1, and our update is a decrement. We count down. It's the exact same powerful logic, just running in reverse. See how flexible that is?
Now, here's something you're going to see everywhere once you start looking at code, and it might seem a little weird at first. Why do programmers always seem to start counting from 0 instead of 1?
The simple answer is, that's just how computers think. Deep down, they start counting at 0. Big concepts in programming, especially things called arrays, which are basically just lists, are 0 indexed. That means the very first item isn't at position 1, it's at position 0. So starting our loops at 0 just makes our code align perfectly with how the computer sees the world.
And because of that, you'll see this pattern all the time. If you want a loop to run 4 times, sure, you could start at 0 and say less than or equal to 3. That works, but the version on the right is what you'll see 99% of the time. You start at 0 and the condition is less than 4. The cool part is that number, the 4, is the exact number of times the loop will run. It's a clean, efficient convention, so get used to seeing it.
All right, you've got the basics down cold. Feeling good? Awesome, because now we're going to level up and look at something really powerful, nesting loops. A nested loop is literally a loop inside of another loop. The key thing to get is the relationship between them. For every single time the outer loop runs, the inner loop runs its entire cycle from start to finish. This is the secret to creating things like grids, tables, or any kind of two-dimensional pattern.
So when would you actually use this? Well, imagine you need to create a simple calendar for a 5-day work week. You have days, and then for each day, you have hours. See that? You have a repetition, the hours, happening inside another repetition, the days. That's a perfect job for a nested loop.
And this is how we build it. The big outer loop takes care of the days. counting from 1 to 5. Then, for each of those days, the smaller inner loop kicks in and runs through all the hours. So for day 1, the inner loop runs completely. Then the outer loop ticks over to day 2, and the inner loop does its whole job all over again.
Let this sink in, because if you get this, you get nested loops. For every one step the outer loop takes, the inner loop runs its full race, from start to finish, over and over again. It's the most important rule to remember.
Whew, okay, we have covered a lot of ground. So let's do a super quick recap of the absolute must-know points. This is the stuff you want locked in for any test or interview.
So here it is, your for-loop cheat sheet. First, the 3 parts: initialization, condition, update. Got it? Second, the execution order. Initialize happens once. Then it's a cycle of check, run, update. Third, the best time to use it? When you know the exact number of loops you need up front. And finally, nested loops are your secret weapon for creating grids and patterns. If you know these 4 things, you are in great shape. And I'll leave you with a final question to chew on. We've used loops to count and build patterns, but how could you use this exact same tool to comb through a massive list, I'm talking millions of items, to find one specific thing? That's the next step on your coding journey.